Question 1b, Part 1. Evaluate the following limits. The limit of negative ln x to the power of x as x approaches 0 from the positive direction. Let's begin by substituting 0 into the function. What we have is negative ln x approaching from the positive direction to the power of x, which is now 0. If we simplify this, we're going to give us negative infinity. Negative infinity times the negative in front of ln 0, that's going to give us positive infinity to the power of 0. Now infinity to the power of 0, that is a indeterminate form. And we know that once we have a limit that is of the indeterminate form, we can apply L'Hopital's rule. But before we can apply L'Hopital's rule, we have to make a change to our function within the limit. In that we want it to be of the form infinity over infinity or 0 over 0. So the first step is we are going to take the function within the limit and equate it to a variable. Let's say y. Y is equal to negative ln x to the power of x. We want this x here to come down. And the way we can do that is we can take the natural log of both sides. We can bring that power down to the front, like that. So now we have ln y is equal to x ln x. Now we can rewrite the right hand side. We can take the x and write it down at the denominator. So this is going to look like this. Ln of negative ln x over 1 over x. Now we can take the limit as x approaches 0 for both sides. So limit as x approaches 0 from the positive direction of ln y, that's going to be equal to the limit as x approaches 0 from the positive direction of ln negative ln x over 1 over x. Now notice if you substitute 0 into the numerator and the denominator, you're going to end up with infinity over infinity. So this is what we want. Now we can apply L'Hopital's rule. And so in this case we have, let's just focus on the right hand side. So we had the limit as x approaches 0 plus of ln negative ln x over 1 over x. Now if we differentiate the top and the bottom, that's what L'Hopital's rule tells us. We differentiate the numerator and then we differentiate the denominator. If we differentiate the top, we're going to have to use the chain rule. So we're going to have to start with what's inside the ln. And if we differentiate this here inside, what we get is negative 1 over x. And then we're going to have to differentiate outside. What we're going to get is 1 over whatever's inside over here, which is negative ln x. So that's the numerator done. Now we can move down towards the denominator. The derivative of 1 over x, that can be rewritten as x to the power of negative 1. When we take the derivative of x to the power of negative 1, the negative 1 comes to the front, and we can subtract 1 from the power. So what we get is negative 1 over x squared. Now we can do some rearranging and simplifying. And if you do that, what we end up with is something like this. And the x at the top, we can cancel that with the x at the bottom. So what we have is negative x left on top and ln x at the bottom. Now we can substitute 0 into the functions, and what we have is 0 on top, ln 0 at the bottom. Remember, we're approaching 0 from the positive direction, so that gives us 0 over negative infinity, and 0 divided by negative infinity, well, that's always going to give us 0. Now, this is not our final answer. This here is the answer to the question, what is the limit of ln y as x approaches 0 from the positive direction? That is equal to 0. But that's not what we want. We want the limit of y. So what we can do is we can try to get rid of that natural log. And the way to do that is to introduce the exponential function e. So let's introduce it on the left hand side as well as the right hand side. So e to the power ln y, and we do the same thing on the right hand side, e to the power of 0. Now e cancels out the natural log, so what we have is the limit of y as x approaches 0 plus. That's going to be equal to e to the power of 0 is 1. Now this here is our final answer, and some of you might be saying, how come this is our final answer? We don't want the limit of y, we want the limit of negative ln x to the power of x. But remember, y is the negative ln x to the power of x. We can rewrite this as the limit of negative ln x to the power of x as x approaches 0 from the positive direction, which is equal to 1. So that's our final answer.